Good morning, everyone, and welcome to the July 2025 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Furman. I'm the Deputy Director of the Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. I'll also be presenting the Agricultural Impacts Update for Pam Knox, who unfortunately is unable to join us today. We also have Shelby Saxon from the Southeast River Forecast Center, who will provide a water resources update. Joining us this month, we're pleased to have Dr. Lee Ellenberg from the University of Alabama in Huntsville, who will be presenting on flash drought in the Southeast. So again, thank you all for joining us. Just a reminder, type those questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next day or so. All right, let's get started with an overview of the climate. We'll start with temperatures. So over the past month, much of the Southeast experienced above average temperatures. The warmest anomalies were found across the northern part of the region, where many locations were 3 to 4 degrees above average, and in some spots even up to 5 degrees above average. In contrast, temperatures across the southern part of the region were closer to average, with a few areas, especially in southern Alabama, Georgia, and parts of Florida, running a degree or two below normal. Puerto Rico and the U.S. Virgin Islands also saw temperatures near average over the past month. All right, next slide. So while temperatures have been above average in many areas this summer, the bigger story has been the humidity. It's really made conditions feel especially sultry and uncomfortable. And it's also helped fuel thunderstorms, some of which have produced pretty impressive rainfall totals, as we'll see in just a moment. So how humid has it been? Well, in some places, it's actually been record-breaking. As we see in the figures on the left, the average dew point temperature since June 1st ranks as the highest on record at both Washington's Reagan Airport and Raleigh-Durham Airport in North Carolina. These are records that date back to the early to mid-20th century, and these values break previous records that were set during the summer of 1994. The effect of all this humidity is also apparent when looking at minimum temperatures. This past Friday morning, for example, Raleigh-Durham dropped to only 80 degrees, which tied the highest minimum temperature ever recorded for that station, which had only happened 4 other times in a record going back over 135 years, and just the second time it's happened since the station moved to the airport in the 1940s. So that's a rather impressive stat. The figure on the right from a recent Capital Weather Gang article helps explain what's been going on. It shows how the Bermuda High and associated heat dome have been pumping warm, moisture-rich air into the region, especially over the past several weeks. Okay, next slide. So when it comes to precipitation, it's really been a mixed bag. Some areas, especially across the northern tier of the region, have seen plenty of rain, while others, particularly in the central part of the Southeast, have largely missed out. That also includes parts of the Caribbean where rainfall has been near to even below average over the past couple of months. And so this kind of feast or famine pattern that we often talk about, that's fairly typical in the summer, especially when the Bermuda High is in control, as we just discussed on the previous slide. Okay, next slide. So one part of the region that's been especially wet over the past month is central North Carolina, and a major reason for that was Tropical Storm Chantal, which made landfall actually along the South Carolina coast on Sunday, July the 6th. And like many tropical systems that impact our region, it wasn't the wind, but it was the rain that caused the biggest problems. The North Carolina State Climate Office put together a really great summary of the event, including the rainfall map that's shown here. You can see 2 bullseyes of more than 10 inches of rain in parts of Chatham, Orange, and Alamance counties. In Chapel Hill, the co-op station in southern Orange County recorded 8 inches of rain on July the 6th, making it the wettest single day in a record that goes all the way back to 1891. That breaks the previous daily rainfall records that have been set over the years during hurricanes Dennis, Fran, and Florence. Just to the south, Moore County also recorded up to 8 inches of rain, and that prompted a state of emergency for the county. Much of this rain also fell in under 6 hours, and so that led to major flooding on several rivers. I think Shelby's going to talk a little bit more about that later. The Haw River in Alamance County crested over 32.5 feet and that broke the previous record that was set during Hurricane Fran in 1996. Further east, the Eno River rose above 23 feet, and that actually smashed its previous record set back in March of 1989 by over 8 feet. So quite an impressive, excuse me, quite an impressive event here in the region. Okay, next slide. And so, as you can imagine, the impacts now from Chantal were significant, especially here in Chapel Hill, where flooding affected several neighborhoods, lots of roads, bridges, and shopping centers. The images that I'm showing here on the slide show one of the hardest hit areas, which was the Eastgate Shopping Center on the north side of Chapel Hill. As you can see, many homes took on water, merchandise in some of the stores were destroyed. Cars were submerged, and even restaurant employees, you can see there on the left, employees at a restaurant had to climb onto counters to stay out of the floodwaters. Emergency crews also performed dozens of water rescues, and tragically, though, at least 6 deaths have been confirmed so far from Chantal, and they're all related to flooding, most actually related to stranded vehicles. Okay, next slide. All right, so let's shift gears a bit and take a look at where we stand so far this month in the summer with regards to temperature and rainfall. If we look at the month-to-date temperature rankings on the left, we see that a few locations across the northern tier of the region are on track to record one of their top 5 warmest Julys on record. Places like Atlanta, Knoxville, Asheville, Charlotte, and Raleigh. And on the right, we see that the warmth, if you take the warmth over the past couple months, that's put several locations on track to record one of their warmest summers on record. So places like Wilmington, Cape Hatteras, Charlotte, Norfolk, Richmond, Roanoke. And we also have places like Asheville and Raleigh, which are actually on track to record or tie their warmest summer on record. Okay, next slide. And so looking at precipitation, we see that wetter than average conditions have prevailed across much of the northern tier of the region so far this month. While drier conditions have prevailed across both the interior and southern portions of the region. That's especially the case across parts of Alabama, Georgia, and North Florida. Seasonally there on the right, the northern tier has been quite wet, and we've seen below average rainfall across mainly the midsection of the region as well as parts of Florida. In fact, Florida has really been on the dry side for much of the year. And in fact, if we look at the drought monitor here on the next slide, speaking of Florida, we see that areas of moderate to extreme drought continue to persist across parts of South Florida, though conditions have improved a good bit across the rest of the peninsula. Some small pockets of abnormal dryness have popped up, though, along the northern Gulf Coast and also across the interior of the region. But overall, nearly 90% of the region remains free of any drought or dryness, which is the highest percentage in over a year. In terms of the Caribbean, generally below average rainfall over the past couple months has allowed some moisture deficits to build on the islands, and so that's resulted in a return of abnormal dryness to parts of Puerto Rico and also all 3 of the U.S. Virgin Islands. Okay, next slide. All right, so looking at ENSO, we see that neutral conditions continue to prevail in the equatorial Pacific. The current outlook and multi-model ensemble show these conditions continuing for the rest of the summer and into the fall. With a possible return to La Niña this winter, we've been kind of tracking this over the last few months, so we'll certainly continue to keep our eyes on that as we head into the cooler months of the year. Okay, next slide. And so looking ahead, looking at the 3-month outlook from the CPC, it advertises above average temperatures and above average precipitation across the region for the rest of this summer and going into the fall. And if we go to the next slide, we'll take a look at the Caribbean, and see that the outlooks there are also advertising above average temperatures, as well as a continuation of the below normal rainfall across the region that we've seen recently. And so that looks to continue here over the next few months. Okay, next slide. And so if we pair that with the 3-month drought outlook, we see that drought removal is expected across Florida, given the outlook and the fact that we're into the heart of the rainy season. And so also no new development is expected across the region, even in the Caribbean, despite the recent dryness and projected dryness. No new drought is expected, at least for right now. But as we know from recent and even past seasons, conditions it can change quickly this time of the year, as Lee's going to talk about in his presentation. So we need to be vigilant and prepared moving forward, regardless of the outlook. Okay, next slide. So looking ahead to next week, we see the temperatures are expected to be above average across the region and most of the country for that matter, with above average precipitation across North Carolina and Virginia, as well as along the northern Gulf Coast. And if we go to the next slide, and there we go. Look out to next week and next weekend. As we, turn the calendar to August already, we see a continuation of above average temperatures with above average precipitation across both Florida and the northern Gulf Coast. I'll also mention that CPC's hazards outlook also includes a slight to moderate risk of extreme heat across much of the region during this time frame, with a slight risk for heavy rain and flooding along the northern Gulf Coast. Okay, next slide. And as we get further into mid-August, we see yet again a continuation of above average temperatures with below average precipitation actually across the interior of the region, with equal chances elsewhere. And so if we go to the next slide, we should be at the summary. There we go. There's the summary for you to look over after the webinar. Also, as always, want to acknowledge all the hard work of our service climatologist, William Schmitz, who helps compile a lot of this information every month, so I appreciate that. And with that, I'll go ahead and turn it over to Shelby.
Thanks, Chris. So we can go ahead and go to my first content slide. Rivers across the Southeast are continuing to be normal to much above normal. As Chris stated, we've been kind of pumping moisture from the Atlantic into our Southeast states, and only on the Atlantic side of Florida are we still seeing some low stream flows. But since the rainfall season has begun there, a lot of the streams there have started to approach more near normal conditions. If we look on the right side at our duration hydrograph for runoff, we see that since June, the July has been a bit drier, and so across the Southeast, we're seeing a bit of a decline in runoff, but we're still in normal conditions, and just thankful that some of that early spring and early summer rainfall has been beneficial to keeping us in normal conditions across the entire Southeast. And we can go to the next slide and get into our state-by-state runoff. In Alabama, where it continues to be kind of the wettest for this year, we are seeing runoff in closer to the 95th percentile. So that is meaning that it's some of the wettest times that we have seen in this time of year for the state of Alabama. Runoff or rainfall hasn't been widespread in the state, and so those early season consecutive rainfall events are really helping sustain that moisture there, as well as having moderately warm temperatures throughout the month. In Georgia, same story, similar to Alabama, where rainfall has been kind of consistent and inconsistent in location, but temperatures remain in those kind of typical summertime, and so that's been helpful for our streams to kind of remain in that above normal area. Jumping to Florida, where we've been in recovery mode this year since dealing with that intense drought in the early part of the year, we see that we're still increasing, and that's a great thing that the rainfall season has kicked in there. And so we're looking at normal flows, and hopefully that can continue through the rest of their rainfall season. And we can go to the next slide, where we'll start with South Carolina. And in South Carolina, this rainfall pattern has been a bit atypical from the rest of our Southeast states. we are seeing a very stark decline in the runoff there. And so if you remember back to some of Chris's slides where rain has been kind of in our northern tier, more in North Carolina and Virginia. That's where the plentiful area has been, not so much South Carolina. And so we are still seeing normal flows, but since that early spring rains, it's been a pretty strong decline. And so we're now not in the above normal for runoff, but we're still looking at normal runoff in that area. In North Carolina and Virginia, where we've continuously pumped some of that tropical moisture in, and the remnants of Tropical Storm Chantal brought high rainfall amounts. We're continuing to stay in the above normal runoff in both of these states. North Carolina being focused more in the central part of the state for most of the rainfall, and the northern tier, we're not really approaching that much above normal category like we were in Virginia, where in Virginia the rainfall has been pretty widespread across the state. And so that kind of is what's separating the two, and where we see North Carolina having only above normal, but Virginia kind of tinging into our much above normal and getting to the highest percentiles for this time of the year. And so we can go to the next slide where we'll look at our current river conditions. And we do have a few bank full conditions still lingering, mostly from Tropical Storm Chantal, and a few just strong convective events. And so along the Cape Fear, where we saw our major floods, we do still have those waves working their way to the Atlantic coast. That is the same story on the PD River, which is in upstate South Carolina through southern North Carolina. And then up in Virginia, those were mostly related to heavy convection and led to some river response in the Chelan Basin. And on the next slide, we'll get a little bit more into some of those river impacts that we saw during Tropical Storm Chantal. And so we saw those impact pictures during Chris's presentation, and talked a little bit about the river stages, but these are the just the amount of flow and how quickly things occurred over that short duration rainfall. And so we particularly saw a lot of this major flooding in the Burlington, Durham, and Chapel Hill, North Carolina area. And so these are three of the observed record or near record floods. I do want to note that on the Eno River and on the Haw River at Bynum, because these were record floods, the gauges either went out or started to experience some noise levels. And this is just because these are levels of stages that we don't typically see. And so the USGS will do a review of these floods, and they'll come through and they will correct this data and make an official crest. And so later in the year, you will be able to see these hydrographs and see things a little bit cleaner with those official crest values in there. But for now, we do still see some of that noise in there. And so we'll go on the next slide where we look at our typical flooding for this time of year. And so in week 30 of the year, minor flooding is not uncommon. We saw some minor floods just in our previous weeks, and kind of that same thing is likely to happen given that it's tropical and convection, and just kind of where that heavy rainfall sets up, things can tend to flood in those areas. Damaging floods are not likely, but those do uptick in just a few weeks as tropical season really starts to kick in later in the Atlantic season. And so on the following slide, we get into Florida a little bit more. And so week 30 there is where we're really starting to see a increase in the trend for flooding. So far this year, we haven't seen major flooding. There were a few in Central Florida due to a few frontal boundaries lingering. And so a few of those systems were monitored for possible tropical development, but didn't quite become named storms while over Florida. But the rainfall that they did provide did lead to some Central Florida minor floods during that time. And just looking at our risk for the remainder of the year on the following slide. We're going to stay at normal risk for flooding for the remainder of the summer and start of the fall. And that's just because we're continuing to look at the convective and tropical influences that are happening that could induce river flooding. And so those are where they happen and when they happen. And so that leaves the whole area kind of in normal risk. As we get more into the fall and winter months where our La Nina chances are increasing, we may start to see areas that have less risk for flooding. But we'll see how the rest of the tropical season progresses before we start to make any assumptions about what might happen in the more October, November timeframe. And so the next slide is just a summary that you can review later. And I will be handing it back to Chris to cover agriculture this month.
All right, great. Thanks, Shelby. All right, so let's go ahead and jump in. And we'll start with a snapshot of the growing season so far. For many watermelon growers in Georgia, conditions have actually been ideal. Frequent rain, warm temperatures. You can see folks enjoying some watermelon there in the picture at the top. But those rains have also brought a bit of a surge in fungal diseases, including southern corn rust, which is shown there in the figures at the bottom. Heat, of course, has been a major factor. Sun scald, for instance, has been a problem. Some South Carolina peaches ended up smaller than usual, and that may have been due to some of the early season cold damage that we saw, followed by the spring and summer heat. But North Carolina's peach season, it actually kicked off a little earlier than normal, perhaps thanks in part to mostly above average spring temperatures. In general, most of our commodity crops are running ahead of schedule in terms of development. There are some exceptions in Virginia, peanuts and cotton, for instance. Insects have also been more active lately due to a lot of the rain, and that's caused some noticeable damage to vegetables and other crops in the region. Okay, next slide. Okay, so looking at soil moisture going down about a meter deep, we're seeing some dry areas in South Carolina and Georgia. On the flip side, though, Central North Carolina, Eastern Florida, and Alabama, of course, have been much wetter, in part due to some tropical activity over the past few months. Soil temperatures have also been running a bit warmer than normal across much of the region, no surprise there. Except in some places, though, where some recent storms have brought some cooling rain. And of course, these temperature and moisture patterns, they, as Pam talks about every month, they really influence everything from planting to root growth to disease risk. So it's really important to track them both before and during the growing season. All right, next slide. All right, we'll take a look at heat accumulation. So in the southern part of the region, we're seeing growing degree days running well above normal. Means crops there are perhaps developing a bit faster than usual. In the northern areas, though, they're lagging a bit behind. Looking ahead, we expect this trend of higher than normal growing degree days to continue. Tifton, Georgia, for example, shown here, that's located in the southern portion of the state, has already built up more heat units than it had at this point last year. And of course, the growing season isn't over yet, so we'll see how that impacts crops as we head closer to harvest. Okay, next slide. So we talked about some of the impacts from Chantal earlier, but of course the storm also really disrupted what really was looking like a promising season for many farms, especially in Central North Carolina. Looking specifically in Person County, which is just north of where the heaviest rain occurred that we talked about 10% of all crops there were flooded, with tobacco, soybeans, and corn taking a major hit. We saw barns and roads collapse. We saw fences torn down, lots of flooded fields, and even farms that weren't directly hit actually felt some impacts. The concern, of course, is that the saturated soils are going to increase disease risk, could potentially lead to lower yields, and in some cases, even where some fertilizer that was put down was washed completely out of the soil. There may be some added cost if those areas need to reapply. And so, this is a good reminder, as we've talked about before, that, a single storm can change the outlook for, an entire region, even if the overall conditions during the season are otherwise favorable. Okay, next slide. Okay, so where do things stand overall? Well, many crops, as I said, are looking pretty good and are ahead of schedule, especially where we've had warm temperatures and the moisture. A lot of the extra moisture and rain have helped them mature faster. Of course, there's been a downside to that with regards to fungal diseases showing up more prevalently, insects causing some problems on fruits and vegetables, and in some cases, they've actually made them unsellable. And of course, Chantal certainly left its mark on parts of North Carolina, not just in damaged fields, but also in damage to infrastructure, which continues to affect farm operations there. And so we'll keep a close eye on how the rest of the season unfolds, especially with the tropical season still ramping up and disease pressures increasing. All right, and so now I'm very pleased to introduce Dr. Lee Ellenberg, who is the Alabama Associate State Climatologist at the University of Alabama in Huntsville, who will be talking about flash drought in the Southeast. Lee, it's great to have you back on the webinar. Thank you so much for joining us, and looks like you're going to be driving your slides, and so the floor is yours.
Fantastic. Can you guys see my slides here and hear me?
Yep, perfect. Both on presentation and audio.
Great. Well, yes, thanks, Elliot, Chris, Shelby. Always appreciate the summary of the climate across the Southeast. I'm honored to be a part of the webinar this month to give some updates on some work I've been doing in the Southeast in partnership with NIDIS and some other partners across the region. So today I'm going to be talking about a project that we developed with NIDIS, looking at flash droughts across the Southeast, particularly looking at its pattern, seasonality impacts, and some of the risk to agriculture. So why do a flash drought assessment? Well, essentially this was developed and kind of mandated from a regional call to action. In 2022, through 2 NIDIS-led workshops and a partners dialogue, we collectively identified flash drought as a top priority. These meetings highlighted the need for coordinated tools, data, communication, all in response to flash drought events. We had 3 main priorities that emerged, at least from the flash drought component, which was to conduct a historical assessment, evaluate tools for rapid onset drought, flash drought detection, and then also provide community or communication and guidance as a product. And again, this is for the Southeast. This is a regional initiative. As we know, the Southeastern climate is different than other regions' climate, and it's very important for us to take a regional kind of customized look at these events. So we'll start. Chris already showed the current drought monitor, and just to recap, this is a combined product that shows drought severity across the region and the nation as a whole. Your yellows are you're just abnormally dry. Once you get into your oranges, browns, you're starting to get drier and drier. And so, well, right now everything, as we showed drought-wise, looks pretty good. So why talk about this now? Well, conditions can change quite quickly. And this is just an example of where we were last year about this time. If you look back in June 2024, that map looks pretty similar to the map that we see today. Yet a month later, you can see in July 16th, that's where we ended up. So things can change really quickly. And so it's really important for us to recognize that and try to develop tools to understand how we can detect this rapid change and really understand the overall climatology of these changes and what those impacts look like. So what is a flash drought? There's a lot of different definitions of what a flash drought is, and there's no one kind of smoking gun definition. But in general, we're talking about the rapid onset or the rapid intensification of drought conditions that usually leads to such an impact, a major impact, such as crop yield, reduced crop yield, crop failure. I'm talking a lot about ag because that's one of the main, but that's not the only impact that you can see from flash droughts. So what causes flash droughts? Well, it always starts with a reduction in rainfall, right? So you start building rainfall deficits. As you start building these rainfall deficits, we get increased evaporation deficit, which means the atmosphere is pulling water out of the ground, but there's no more water, and so you build up these deficits. As you decrease that moisture, you're going to further increase the temperature, and as you increase that temperature, you further increase that evaporative demand. This all resulting in declining soil moisture, and you end up in this really this cycle that can spin out of control if conditions stay the same. And so this is what leads to the rapid intensification. It's not building deficits of 2 inches, 1 inch over at a time. This is basically the spigot cuts off, and you get into this rapid cycle. And so we talk about two different kind of concepts of flash drought. One is that rapid intensification in the onset, but there's also that duration component. And so in the Southeast, we experience a wide range of flash drought type conditions. And what I'm highlighting here is two different components. So one is a well-known drought we saw in the region in 2016, and another in the fall of 2019. The 2016 drought, in many cases, was a much bigger drought, especially region-wide, and its duration. However, it was that September timeframe where we saw things really drop off the ledge, and you had this rapid intensification where you had drought conditions across the Southeast, but then by September, you're looking at nearly half the Southeast is in some level of D2 or D3. And so that's what we mean by rapid intensification of a drought that's happening. And we consider that a component or a variation of flash drought. And then the opposite is, or not the opposite, but another component in the 2019, we saw a flash drought that spiked, had a rapid intensification and a short duration. In fact, the drought monitor probably underreported this because it was such a short duration. So this was just essentially, it just didn't rain in September. We had a month of no rain, and conditions rapidly declined. And so this resulted in major impacts, especially to the livestock industry and forage producers. And so this is what I mean by there's flash drought. There's a lot of definitions, but the reality is what we're talking about is a rapid intensification of conditions that result in some kind of impact. So how do we detect flash droughts? Well, what we're trying to do is detect that rapid change. So as I mentioned, flash droughts are characterized by this rapid onset or this rapid intensification. And sometimes it can just be in a few weeks, often too fast to be captured by traditional metrics like your 30-day SPI, your 60-day SPI, right? They may wash out these short-term impacts. And so we want to try to identify these rapid changes. And so we adopt a method inspired in part by market volatility. But this was first produced with Osman et al. In his paper, where the goal is to detect a sharp, significant departure from recent conditions. And so to do that, we're comparing short-term versus the recent value. So the current week versus the past month. How quickly is it dropping? Is it dropping really quickly? The magnitude of that drop, and then where does it end up? Right, so we're looking at a short-term, a rapid decline, and then once it hits a certain threshold. A lot of times this is about the 20th percentile. That means 1 in 5 year kind of event. And this associates with the D1 level on the drought monitor. And then you want it to be sustained at some level, right? So maybe 2 or 3 weeks. So we're looking at something that drops quickly, gets to a critical level, and stays there for a short time. And then that's kind of the general idea of trying to understand how we monitor flash droughts. So In this project, we use a couple different metrics, but they all kind of follow this consistent logic of sustained decline, significant and then sustained decline. So for this project, what we looked at, so again, what we're trying to understand is flash drought across the Southeast. How does it happen? When does it happen? How often does it occur? Are there regions where it occurs more than not? And so we used 4 common metrics that are often used in monitoring across drought across the states of the Southeast. Soil moisture almost always gets basically heightened to the most critical variable for flash drought, because it's measuring soil moisture, right? Exactly what crops are using to produce their biomass. So we make again, to trigger that, we're looking at a rapid decline below the 20th percentile. And again, what we're capturing is that surface moisture stress for plant function. The next is the Lawn and Garden Index. This is a product that we produce out of the state climatologist office in Alabama. And what this is looking at is like a 21-day weighted precipitation. So kind of looking at effective precip, how much rain is actually being used today as of the past rainfall of the past 2 or 3 weeks. Again, we're looking at a rapid decline below a certain value, and this is looking at that short-term dryness in shallow-rooted vegetation. The third metric we use is the evaporative stress index. So again, if you look back at this, the figure I have on the right and the cycle I have there, again, what we're looking at metrics that can best describe this rapid kind of spiraling cycle. And so evaporative stress is an important component to that. Again, what I'm saying when I say evaporative stress, this is the amount of actual evaporation that's happening across the surface versus how much is actually being demanded from the atmosphere. So the bigger that deficit gets, the drier things are and the more stressed the system is. So again, we're looking at a sharp decline over a couple weeks at a certain threshold. And what we're showing here is this is the vegetation water stress. And this is from a satellite Alexi model. And this is able to see stress often before we start to see those vegetation signals. And then lastly, the drought monitor, which is an expert synthesis of all the indicators, right, that comes out once a week. There's several different ways to determine flash drought, but to match with what's been done before and within the context of the 3 I said above, we're looking at a 2+ category degradation in a 4-week period. So it's a pretty sensitive flash drought metric for the drought monitor, but I think it maps pretty well with what we're looking at in the prior indices that I mentioned. So what did we find? All right, so what I'm showing here is the results of this study. So you can see the map on the right. I have 4 different maps. Each one is associated with the indicator that I use. So the soil moisture is top left, ESI top right, LGI bottom left, the drought monitor the bottom right. And so across all metrics, flash drought occurred somewhere in the Southeast nearly every year. So we looked at years from 2001 to 2023, where we had metrics for data for all these metrics. However, each of these drought metrics tell different stories. So soil moisture, right? It's the most sensitive metric as we found. This captured the highest number of events, and that's due to its tie to these early stage surface drying. So the colors on these maps are essentially showing how many flash droughts we detected over this 22-year period. And so when you look at, on average, we're looking at 24, 23, across the different metrics. Essentially, that's where it's like, well, just about every year, on average, we're experiencing flash droughts defined by these metrics. The LGI aligned really well with the seasonal moisture demand and looked really well, aligned really well with the soil moisture as well. However, it's much less effective in the early spring and fall. That's just because it's pinged to an average demand, and that drops off in the spring and fall. Also, we noticed that it's way too sensitive in the dry season in Peninsular Florida, right? So this is based off a predefined demand curve, and so just not really appropriate for south of the Panhandle, just given the different monsoonal patterns of that region. The ESI, we're looking at vegetation stress, similar to soil moisture, but a bit weaker in the seasonality. This is probably due just to the fact that it's a standardized product, but it shows the best detection and sensitivity during fall seasons when there's less moisture in general in our region. And then lastly, the drought monitor, it detected much fewer droughts, so 4 on average across the region for that year. but those overlapped with the most critical periods and most impact. So the drought monitor is less sensitive, but the ones that it does identify are a bit more impactful. We can look at all these together. So if I combine all these metrics into one general flash drought climatology over the Southeast, this is the map you get. Less on focusing on the numbers, but more on the patterns, right? Seeing where these hotspots are, specifically around South Carolina, Georgia, along the Mississippi River Basin, or the Delta there, and even up into Virginia. The heat map I'm showing on the right is just how these all interacted with each other. Again, LGI and soil moisture, I think they related the most. ESI, a little more generic, but again, identified some of those fall droughts best in the drought monitor. So the drought monitor is not going to relate well to others just because there's less, but when there is a drought monitor, it most likely aligned with the soil moisture index. So let's look at what these indicators look like across a couple examples. So if you're from this region, we all remember the 2016 drought, the 2019 drought, and then really in our recent memory, the 23 drought. And so this is a time series of essentially the percent of area under any one of these flash drought categories. So if there's a pixel that says flash drought, we calculate that area, we sum it up over the whole region. So the max here would be 100%. And so I'm looking across the different metrics. So blue is ESI, orange is LGI, green is soil moisture, and red is the drought monitor. And this is just showing how these metrics identify and pick up on flash drought. And so in general, what we can see is, just like I showed earlier, soil moisture is a bit bullish in that, it detects that short-term dryness really quickly. And right behind that is the LGI. And the soil moisture and LGI are essentially the canary in the coal mines of these flash drought events that occurred. They popped up really quickly, showed intensity. And then ESI a little bit delayed in that fact. The 2019 was a bit better. It performs better in those fall droughts. And the drought monitor also, it peaks, but just slightly later, and in some cases after the soil moisture and the LGI have already recovered. So again, we're showing the percent of area across these different, and just kind of how the metrics themselves pan out and their frequency and being able to detect dry conditions, specifically rapidly drying conditions. So the seasonality of these flash droughts. So here I have a map. So this is looking at, again, top soil moisture, ESI, LGI, and then the drought monitor from top to bottom. And then from left to right, I'm looking at spring, summer, and autumn, or the fall. And so what you can generally see to take away from this slide is that naturally the droughts typically start in the lower part of the region and move their way up, just because that's just how the summer evolves, the sun angle, et cetera. However, another real important component here is we do see kind of two seasonal peaks, both in this early summer, this May-June period, and then also in the fall. And so again, we know that the fall is typically our dry time of year anyway, but we also see another slightly muted but distinct peak in the May, June, early July periods. So why that matters? Well, it makes a lot of sense, because if you look at the water balance across the Southeast, we are a very abundant region. We're very blessed with average annual rainfalls anywhere from 50 to 70 inches, right? That's a lot of rainfall. However, our ecosystems have evolved in that environment, right? You look at a satellite image and we're green. We have a lot of vegetation. We have a lot of demand. We have a lot of water use, natural water use. And so when you look at our hydrograph across the Southeast, what you can see is actually there are two periods where on average it's not uncommon for us to experience water limited conditions. And sure enough, this pops out in our fall and in that early summer, May to June period. So this kind of, it was a foreboding analysis of when we're going to expect to see flash droughts the most, and that's just when we might have water limited conditions for 1 to 2 to 3 weeks at a time, and that's not necessarily uncommon. So what does that mean, and what does it matter for us to understand this? So as I mentioned at the top of the presentation, I want to talk about impacts and specifically to agriculture. Agriculture is not the only impact of flash droughts, but in this case, what we're going to dive in and look at what these flash droughts look like. So what do flash droughts look like, especially in context of agriculture? Specifically, not all flash droughts are the same, right? So you may have a flash drought every year, but if that doesn't align with a critical period in crop stage, it may not have an impact, right? If you have a flash drought in February, it might not have any impact because you haven't planted yet. However, we do know that these short duration droughts can cause major yield losses if they coincide with very sensitive stages. And so their rapid onset makes them really hard to monitor and plan using traditional drought tools. So here's an example of a really impactful drought, flash drought. So in 2022, I don't know if anyone remembers the 2022 flash drought. Probably not, because it was localized and just really to northwest Alabama. The region experienced about 2 weeks without rainfall, and then another week of barely any, and then another week of no rainfall. But what this did was triggered a really sharp decline in soil moisture. We saw this in the LGI, the Lawn and Garden Index, where we saw a rapid decline below 1. We saw in our metrics would identify this as a flash drought. You can see how the different metrics I used in the analysis. Again, green is soil moisture, orange is LGI, blue is ESI, and red is the drought monitor. And so it's right during this period that corn reaches its most critical stage, right during a 3 to 4 week period between the end of June and that 1st of July. And so as a result of this 2 to 3 week flash drought, yields were below 40% on average across the counties affected, despite near normal precipitation for the season, normal precipitation for the year. So if you're looking climatology back, nothing happened in 22. It was a normal year. Growing season was roughly normal. However, it was this 2 week period had major impacts as a result of this flash drought. So we want to be able to understand these impacts and tie this. That way we can not only see how often flash droughts occur, but how impactful are they across the region. So what we did is we want to link flash droughts to these very sensitive stages where 1 to 2 weeks of rain can make a really big difference in crop growth and the ending yield and biomass. So for each crop across the Southeast, we looked at 4 major crops: cotton, corn, soybean, and peanuts. And we defined sensitive growth stages. So that's tasseling, the flowering, the pod fill. We worked really closely with Extension, did a thorough agronomic literature review, and defined these growth stages based off the growing degree days. Then we basically used these growing degree days to build up a crop model across the region, a crop calendar, I should say, across the region, allowing us to estimate when crops are most sensitive to drought. Now, remember, this is on average, so this is over 23 years, 22 years. And so it doesn't mean that every year is going to be like this, but on average, this is when a crop planted at this time, at this location, is likely to be within a threshold of its most moisture-sensitive period. We were able to validate these models using some of the NASS weekly crop progress. And what we actually have now is a gridded crop calendar of when these crops are most sensitive to short-term moisture deficits. Obviously, a drought at planting, a drought at all the different stages can be impactful, but this is that critical period that if you don't have water during this exact time, you can see the most critical departures in yield. And so we built this gridded crop calendar across the Southeast, across all these different, these 4 different crops. So now we want to align. All right. So how often do these does a flash drought occur when this most sensitive period exists? Right. So we want to align the flash droughts with the timing of those most sensitive crop stages. So we look at flash droughts. We matched all the flash droughts to the crop calendars, and we calculate 2 probabilities. All right. So the first probability is the likelihood that a flash drought occurs during its crop's most vulnerable period. So this is essentially helping us understand how vulnerable any given year a crop might be to flash droughts. And then the second probability we look at is what's the probability or the likelihood that a crop is in a vulnerable stage when a flash drought hits. So this is looking more towards exposure, right? So this is saying you can kind of look at the difference of these. The first one is we're dividing by all years, right? So any given year. And then the second probability, we're looking at only the flash drought years. So only if a flash drought happened. And what this method helps us to quantify is the vulnerability and exposure of flash drought, both in the timing and that impact potential. All right, so this is the first. All right, so flash drought vulnerability. So this is the probability of flash drought given a crop was in its sensitive stage. So this is across all 23 years. This shows the likelihood that a flash drought strikes during the most critical stage. So like that's flowering, the grain fill, the pod filling, depending on the crop. Here I have corn, so this would be silking. And so what we're saying is on average, there's a 15% annual chance that a corn will face flash drought on average across the region. However, there are some pretty big hot spots, and in some cases, this could be up to 25 to 30%, right? Highlights in Southwest Georgia, Northeast Alabama, Northwest Tennessee, you can see where those areas are. And so now it's like, well, 15%, that's about, again, the flash drought, we're looking at 20 percentile. But then you see there are certain areas where that actually could be, 1 out of 6 years, 1 out of 3 years, right? So that could be really informative and insightful to farmers, advisors, managers, especially when you're looking at, optimizing planting dates and irrigation or resilient hybrids. So this is again a representation of the vulnerability. Here we have corn, and I've masked out areas where corn is typically not grown, but we did this for all 4 crops, right? So you can see corn, cotton, soybean, peanut. Again, on average, about 10% chance any given year, but again, that can come up to much higher values depending on where you're looking at and what crop you're growing. So the next thing we looked at was that exposure, right? So this shows, so now we're looking at the probability that a crop is in its sensitive stage given that you're in a flash drought. So this is now dividing by only the number of flash droughts. So this is going to be dependent on if this is a hot spot region for flash droughts or not. So this shows on average, there's a 20% chance that when a flash drought occurs, peanuts, in this example on your right here, are in a critical development stage, such as the pegging or pod filling. But in certain areas, that might increase to 1 out of every 2 flash droughts. So you may not have a flash drought every year, but when you have a flash drought, there's a 50% chance that it's going to align with a very critical period. So what this information helps us do, right, this can help planners and drought monitors, right? We can anticipate, if there's a flash drought coming, there's a really good chance that we're lining up with a bad scenario with our crops, right? We can target early warnings and advisories for these high-risk areas, and we can start to integrate this crop stage timing into seasonal outlooks and potentially into our drought monitoring tools. And so again, likewise, we did this for all 4 different crops across the region and masking out where they were not typically grown. Again, this is pretty conservative mask. There's probably areas where we're showing that there are no crops grown of that type. But again, what this shows now is, previously we had the 10 to 15% chance of a flash drought. Now we're saying, all right, 20 to 30% chance that these are impactful when they do occur. So again, this helps inform the planning and the monitoring perspective of the regional aspect of flash drought impacts. So in summary, I'll won't read through all of these, but flash droughts occur almost every year, and especially in some of the hotspot areas. Combining these indicators improves our detection. They're very different, and they can identify different context and aspects of flash droughts. We have 2 distinct periods in early summer and fall. These timings are really crucial, so we need to look at the crop growing cycle and in context with these the timings. And this analysis of the vulnerability and exposure by tying in the flash drought seasonality and the timing with crop planning and the crop development allows us to maybe support targeted warnings, adaptive management decisions, proactive planning. So the next steps of this work is really we're working closely with NIDIS to produce communication pieces. We'd love to produce some of these daily, weekly products to assist in some real-time monitoring. And then, future investigations into impacts beyond agriculture, because we know they exist, and looking at the changes over time of these frequencies and patterns. So that's it for me. I want to thanks so much for allowing me to present. I'll stop here. I think I might have run over a little bit of time, but just want to point out that this work was funded by NIDUS for the Southeast Dew system. Really appreciate that, and was very appreciative of the Cairo Institute at the University of Alabama for helping make that happen.
Thank you, Lee, so much for that presentation. My slide here real quick. So thank you again. My name is Elliot Wickham. I am the Southeast Drought Regional Coordinator, or the Southeast Dews Coordinator for NIDUS. Please go ahead and enter any questions you have for our speaker in the question box. We have time for a few. This webinar, the summaries and the recording, feel free to share them. We will send out a link to this recording either or a little bit later this week, probably tomorrow. And then the next webinar that we'll have a month from now in August is the value of drought impact reporting and the role it played in the 2023 Southeast flash drought. And please help us improve our webinar with our post-webinar survey. And if you have any questions at all, please feel free to reach out to me at elliot.wickham@noaa.gov. All right, so we have one question here. Lee, this is, I'll aim this at you, but open for discussion. Is there any way to distinguish between a flash drought and the beginning of an extended period of drought?
Is any way to, well, that's a great question. And I mean, is in terms of distinguishing if the flash drought will be a short-lived one or it may turn into a longer-term drought. I don't know. I think it would just really depend on our ability to forecast beyond those 2 or 3 weeks. So, and as good as we can forecast our seasonal 4 to 2 month weather forecast is probably as good as we can know. In terms of the seasonality, I think it's more likely in the Southeast that those short-term droughts may turn into longer periods in the fall, just because that is our dry period, our dry time of year. So that would be a potential, but it's a good question. But I think it really just depends on our ability to forecast, which is getting better, but we still have a ways to go.
And Lee, I'll also tack onto that too. I think I use fortunate with air quotes here because it's not fortunate anytime that we have a drought, but fortunate in the sense of the last 3 flash droughts that we've had, the big ones, 19, 23, and 24, that they haven't developed into severe longer-term droughts. It hasn't been a flash drought that's kicked off a longer-term drought. So we just haven't been in that scenario yet, but that doesn't mean that couldn't happen in the future. We do have one question, Lee. They're asking if your work is published, or is this work published? I'll let you go ahead and answer that question.
Great, yeah. It's currently in review in a peer-reviewed journal, Applied Meteorology and Climatology. But we're also preparing a separate kind of companion document, maybe more lay-oriented, or at least more comms-based and not like peer-reviewed, thousands of citations kind of thing, with NIDUS. So I think you'll be able to see both of these documents coming out in the next, say, 2 to 3 months, hopefully by this fall. So yes, it's in the process of being published in 2 different avenues.
Great, thanks. And another question is how do flash droughts occur? How often do flash drought occurrences overlap with long-term ones? Go ahead if you want to answer that.
That's not something I've looked into specifically. Again, as Elliot mentioned, we've been pretty lucky in the past several years that we haven't had a long-term drought since really the 2007-8 event. However, I haven't looked at in particular how often that occurs. We have long-term droughts here in the Southeast about once every decade and a half, and so we're kind of sadly kind of getting due, just climatologically anyway. But I haven't looked at that specifically, but it's a great thing to try to better understand.
Yes, and that phenomenon has happened in other regions where it's either started with a flash drought or rapid onset, developing into a longer term drought, or more of a persistent drought that has then turned into rapid intensification or flash drought. So even though it hasn't necessarily, we haven't looked into that here, it has happened in other areas. So it is technically possible for it to happen for us in the future at some point. I think that's it on questions, unless there's one more. We got one more minute, but again, thank you so much to our presenters for covering so much great information today. And if you have any questions, feel free to reach out to me at elliot.wickham.noaa at noaa.gov. And in relation to slides being recorded, so it's not just a virtual recording; it's a video recording, so you'll see the slides go through. We do have one question. If someone has questions about the work, can they contact you, Lee, offline about it?
Yes. Happy
Okay.
to discuss further to anyone
Okay.
that would like to. So you have,
And
you'll send my email, or it'll come through you.
I think the easiest way to do it is if you have questions for Lee, shoot me an email and then I can forward you on to Lee. That way, just do it that way if you're comfortable with that. So.
Yep. Perfect.
Perfect. All right. Thank you everyone for today. And again, appreciate your time and tuning in. And thank you everyone for presenting today. And we will see you in a month in August. Thank you. Bye.